Hello, this is a video of examples 1 and 2 for Geometry Topic 1, Lesson 1. And since this is the first video, we're going to look through the lesson's essential question, which is how are the properties of segments and angles used to determine their measures? The vocab we're going to learn in this unit: collinear points, line, plane, point, postulate. And in the end, you will be able to use properties of segments and angles to find their measures. First thing you probably have done or will do is with your teacher, you'll do an explore and reason. I'm skipping over that. Okay, the beginning concepts for geometry. We have undefined terms, believe it or not. They're not defined. Number one, a point. A point is a location and has no size. It has no size whatsoever. It's just location. The diagram for it is a dot with a letter. And notation, if you're going to talk about point P, then it would have just the letter P with no, well, you'll see, it has nothing else, just the letter. A line is an infinite number of points on a straight path that extend in two opposite directions with no end and has no thickness. So even though often in a diagram you'll see a line drawn, it actually has no thickness. It goes on forever and ever to the left and right in this case. The diagram for it would have, it sometimes can have a scripted letter to represent line L, like it's written here, notation, line L. Or you have to use 2 points, and only 2 points, to name a line. This is line AB, which could be written like this, with a line above it with arrows on either end. Or I could have said, or this document could have said, line BA. You can have the letters in either order, just 2 letters. Another thing with no thickness, I think that's why it's undefined, because you can't really define things that don't have any thickness, is a plane. A plane is an infinite number of points and lines on a flat surface that extend without end and has no thickness. So if you think about a wall that continues forever and ever, up and down and left and right, or a floor that continues forever and ever, cuts through the trees and whatnot, that's a plane. It has no thickness. Now, a plane can be named with just the letter M. Like notice in this diagram, there's no dot there because it's plane M. Or if you have 3 points, you can name a plane. You need 3 points to name a plane, where you only needed 2 points to name a line. 3 points, as long as they're not in the same line, they can define a plane, and we would call it plane XYZ, or it could have been, you could have switched those letters around in any order you want. You'll get more familiar with these as the weeks go by. Moving on to some more concepts. Here we have defined terms. In geometry, new terms are defined using previously defined or known terms. So far we've talked about the undefined terms. Now here's a description of a segment. It's a part of a line that contains 2 points called the endpoints. So a line went forever and ever, where a segment has an endpoint A and endpoint B. And that's where you'll have in the notation those letters A and B. Notice it doesn't have an arrow on either end like it did for the line. So that's how you write a segment. A ray is part of a line that consists of one endpoint and is all the points of the line in one side of the endpoint. So it's kind of like the line is chopped off and it ends at M. It goes from M through N forever and ever. And that's key, that the endpoint is M and it goes through N. That's how you would need to write it. Unlike a segment could start at A and end at B, or it could start at B and end at A. So this could have been written as segment BA. With a ray, you have to write the order must be from the endpoint through the point. So MN, ray MN. We have 2 opposite rays. Opposite rays are rays with the same endpoint, I should say. For example, here we have ray starting at T going through S, and an opposite ray would be starting at T going through U. Notice the opposite rays form a line. They have to have the same endpoint, though, to be opposite rays. You couldn't say ray SU and ray TS, because then you'd have this overlap. They have to have the same endpoint. That's a key. And we have an angle as the last term. An angle is formed by two rays with the same endpoint. Each ray is a side of the angle, and the common endpoint is called the vertex. Again, a lot of terms here. Your teacher probably will go over this in class. Q is the common endpoint. QR is one of the rays. QP is the other ray. Sometimes you could have a number, or yeah, it's usually a number. It's not a letter. There's a number inside there. So we could name this ray angle 2, angle PQR. Now, if you're going to use 3 letters, you need to have the middle letter needs to be the vertex. And if it's the only angle that's on the paper, you can get away with naming it with just that endpoint. I mean, just that vertex. Not advisable though, especially if there's another ray. If there was another line coming out of here, another ray coming out of here, you wouldn't be able to call it angle Q because you wouldn't know which of these angles you would be talking about. All right, there's some background. Example 1, finding lengths. How can you find the length of segment CD? Notice I said segment CD because it has that bar above it. CD goes from 1 to 4, and that's what you can use. In fact, let's see their solution. Oh, that's a lot of words there. From 1 to 4, there's 3 segments. 1, 2, 3. Or there's three values. So segment CD has a length of 3. Let's see if you can do that on your own with this one. Please pause the video and solve this one, and then push play when you're ready to see the answer. On this diagram, they want us to find the length of AC. A goes from the -3 all the way to 1, so I'm going to count. 1, 2, 3, 4. I believe the answer is 4. Let's see how I do. 4, and the answer is 4. Hopefully that's what you got. If not, you can go back to the previous one and maybe get some help from that or from your teacher. And that is it for example 1. Before we go to example 2, let's talk about this postulate. The ruler postulate. Every point on a line can be paired with a unique number. This number is called the coordinate of the point. For example, wow, this is hard to see. Point X is right above the 3, so I would say the coordinate of X is 3, and the Y can be paired up with the 7, so the coordinate of Y is 7. And if I had to come up with a length of segment XY, I could just subtract those two numbers. I think that's coming up on this problem right here. Yes, it is. Distance on a line. The distance between any 2 points, X and Y, is the absolute value of the difference of their coordinates. Now, why they say absolute value? Well, if you were to subtract 3 minus 7, you get -4. You can't have a negative length of something. Everything has a positive length. So that's why it's the absolute value. So if you go 3 minus 7 and get -4, take the absolute value of that. The length of it is 4. The easier way for me is I go the larger number minus the smaller number. 7 minus 3. Just be careful, because if one of them is a negative number, you need to have those skills on being able to subtract negative numbers. All right, let's see what we have here. Example 2. What is KL? Meaning, what's the length? When it's written like that, it's asking you what's the length. They're talking about using the ruler postulate. KL, from K to L looks like from 12 to 16. So they should go, yep, 16 minus 12 is 4. Or the absolute value of 12 minus 16 is 4. Either way, you're going to get 4 as long as you take the absolute value. Hopefully that makes sense to you, because now you're going to try one on your own. 2 of them, actually. Please pause the video and try these 2 problems on your own, and then come back and see if you got them right. The first one's asking for JK. From J to K, I see it's 5 to 12. I'm going to go larger minus smaller, so I don't have to use the absolute value. 12 minus 5 is 7. I am correct. And then for KM, from K to M, 12 to 27. Now, let me write this out longhand. 27, I hate that, how the screen doesn't do that. It doesn't like to stay on. Oh well. 27 minus 12 is 15. Let me finish this off. Sorry you can't see what I'm typing. For some reason it doesn't show up. Let me double check that. K and M, 27 and 12. Yep, 27 minus 12 is 15. And that was the answer. Hopefully that's what you got. Moving on. Actually, this is the last problem. So what I want to show you now is the possible problems that you could do out of the text. Your teacher hopefully has assigned some of these or all of these. The possible problems are 16 through 21, 9 and 39, and number 36. Make sure you know which ones your teacher wanted you to do. Believe it or not, that is the end of this video for examples 1 and 2 in topic 1, lesson 1. Thank you for listening and watching.